Hello, my dear friends. Welcome back to another show. This time, differentiation 2020 JEE main. January and September shift. In the year 2020, what happened? There was a COVID wave, correct? So they conducted the exam instead of April, they conducted in the month of September. Okay, instead of April, there was a lockdown in the month of March, April, right? So they conducted the exam in the month of September. January and September shifts I'll be covering. So number of questions asked from various topics are shown here. Okay, different topics. Derivatives using functional equation, one question. Second order derivatives, three questions. Derivative of one function with respect to another function, one question. Implicit function differentiation, three questions. And derivative of a composite function, one question. Derivatives of inverse trigonometric function, one question. Miscellaneous, one question. Totally we have 11 questions altogether from the January and September shift of the year 2020, the differentiation topic. We'll discuss the questions one by one. The first question we have given y square plus log of cos square x equal to y for x belongs to the open interval minus pi by 2 pi by 2. Then which of them is correct? Various options are given. You can see the first derivative, also you can see the second derivative, correct? So we need to find the derivative at 0, correct? 0 is a point highlighted here, y dash of 0 and y double dash of 0. So we'll find out at x equal to 0 what is the corresponding value of y first. Then we should differentiate it 2 times and substitute the values. Okay, want to find the derivative at x equal to 0, also find the second derivative at x equal to 0 and verify which of the option is going to satisfy. Okay, given y square plus log of cos square x equal to y, correct? So from there you put x equal to 0 and find out what is the corresponding value of y. Put x equal to 0, put x equal to 0, what we get? Putting x equal to 0, y square plus log of cos square x, y square plus log of x equal to 0, put cos 0 is 1, correct? Cos 0 is 1, 1 square is 1, log 1 I'll get is equal to y. Log 1 to the base e it is. Log 1 to the base e is 0. So y square plus 0 is equal to y I'm getting, correct? Y square plus 0 is equal to y. This gives y square minus y equal to 0. Y square minus y is equal to 0. Writing all the terms to one side. Y is common. So y minus 1 equal to 0. A into B 0 means what? Either A equal to 0 or B equal to 0. Y equal to 0 or y equal to 1. Y equal to 0 or y equal to 1. I am getting two possible values of y. When x equal to 0, y equal to 0. One possibility. When x equal to 0, y equal to 1. So I need to find the derivative of the function at x equal to 0, y equal to 0. Also I need to find the derivative at x equal to 0, y equal to 1. Also I need to find the second derivative also. So given equation you consider and differentiate. Okay. Given y square plus log of cos square x. Given y square plus log of cos square x. Log of cos square x, you can write 2 log of cos x using property of log. Log m power n is n log m. Log of cos square x is 2 log of cos x. 2 log of cos x is equal to y, correct? Differentiate this with respect to x. Differentiate with respect to x on both sides. Derivative of y square is 2y into y dash. Derivative of log of cos x is 1 by cos x into derivative cos is minus sine. So minus sine by cos becomes minus tan. So this will be minus 2 tan x. Directly I wrote is equal to derivative of y is y dash. Log of cos square x written as 2 log of cos x. Log x power y is y log x. The power 2 is brought down. Constant into variable. Constant keep as this. Derivative of log of cos x 1 by cos x into derivative of cos is minus sine. So minus sine by cos minus tan. Now we can find out at x equal to 0, y equal to 0, what is y dash? Put x equal to 0, y equal to 0, what do you get? Put x equal to 0, y equal to 0. Put x equal to 0, y is equal to 0. 2 into 0, this part is gone, y is 0, correct? So 0 minus 2 into tan 0 is 0, correct? Minus 2 tan 0 is equal to y dash. Therefore, I am getting y dash equal to 0. Y dash equal to 0. Next, I will put x equal to 0, y equal to 1. Put x equal to 0, y equal to 1. Put x equal to 0, y equal to, what do you get? y is 1, no? 2 into 1 into y dash, 2y dash, minus 2 into tan 0 is 0, correct, is equal to y dash. Tan 0 is 0, this part is gone, so 2y dash minus y dash, I'll get y dash equal to 0. So in both the case I'm getting y dash equal to 0, in this case as well as in this case. When x is 0, y is 0, y dash is 0. When x is 0, y is 1, in that case also I'm getting y dash equal to 0. So first derivative we got. I need to find even the second derivative. See, according to the option, y dash of 0 equal to 0 is not found. Y double dash of 0 is there. Correct, that is not, still we didn't get y double dash of 0. We need to find the second derivative. So consider this equation now. Consider 2y y dash minus 2 tan x equal to y dash. Consider 2y y dash, consider 2y y dash minus 2 tan x is equal to y dash. Differentiate this with respect to x again. Differentiate with respect to x again. What we get? 2 into derivative of y into y dash. Apply the product rule. Y into y double dash plus y dash into derivative of y is y dash, minus 2 into derivative of tan x is secant square x, derivative of y dash is y double dash. Now I can put x equal to 0, y equal to 0, y dash equal to 0. Okay, in this equation I'll call this as star. Put x equal to 0, y equal to 0 and y dash equal to 0. What we get? Put x equal to 0, y equal to 0, y dash equal to 0. Star becomes what? 2 into y is 0, 0 into y double dash 0, y dash is 0, 0 into 0, 0, minus 2 into secant 0 is 1, 1 square 1 is equal to y double dash. Therefore y double dash is minus 2 I'm getting. Y double dash is minus 2. Now put x equal to 0, y equal to 1, y dash equal to 0. Now put x equal to 0, put x equal to 0, y equal to 0, y dash equal to, y equal to 1, sorry, y equal to 1, y dash equal to 0. Y equal to 1, y dash equal to 0 in star. Star implies what? Equation star implies. Put x equal to 0, y equal to 1, y dash equal to 0 in equation star. What do you get? 2 into y is 1, 1 into y double dash, y double dash. Y dash is 0, correct? 0 into 0, 0 there. Minus 2 into secant 0 is 1, 1 square 1 is equal to y double dash. So what do you get? 2y double dash minus y double dash, that is y double dash is equal to 2. So I can conclude from these two equations that mod of y double dash of 0 is 2. Mod of y double dash of 0 is equal to 2. Correct? Mod of y double dash of 0 equal to 2 is present here in option D. If you add mod of y dash of 0 and mod of y double dash of 0, I'll get 2 only. Y dash of 0 is 0. Y dash at x equal to 0 is 0. Correct? Also note that mod of y double dash of 0, mod of y double dash of 0 plus mod of y dash of 0 is equal to how much? 2 plus 0, which is equal to 2. So answer is option D. Correct? This can't be the answer. Sum of these two is given to be equal to 3. I am getting 2. This is not possible. Y double dash of 0 equal to 0 is not there. I am getting plus or minus 2. So mod of that is 2. Even this is not possible. If you add these two, getting 1, that's also not possible. I am getting sum as 2. So answer is option D. Question asked on 3rd of September, first shift, JEE Main 2020. Move on to the next one. A plus root 2b cos x into a minus root 2b cos y equal to a square minus b square. A is greater than b is greater than 0. Want to find dx by dy, pi by 4 comma pi by 4. So we'll differentiate this by using the product rule. Given equation, apply UV rule or the product rule. First into derivative of second plus second into derivative of first. Just apply the product rule, and what is asked is dx by dy. Be careful. Dx by dy is a reciprocal of dy by dx. Dy by dx and dx by dy are reciprocals. The first derivatives are reciprocals of each other. Provided dy by dx is not equal to 0, dx by dy is 1 by dy by dx. You must know that. So given equation to differentiate with respect to x and find dy by dx, substitute the point x equal to pi by 4, y equal to pi by 4, get dy by dx, finally you take reciprocal. Okay. So given equation is a plus root 2b cos x, a plus root 2b cos x into a minus root 2b cos y is equal to a square minus b square. Differentiate this with respect to x. Differentiate with respect to x on both sides. Applying the product rule. First function keep as it is, a plus root 2b cos x. Differentiate the second bracket. Constant derivative of a is 0. Constant a and b are constants here. Derivative of constant is 0. Correct? 0 minus root 2b into derivative of cos y is minus sin y. Minus sin y into derivative of y is y dash. Correct? Derivative of cos is minus sin. Minus sin y into derivative of y is y dash. Plus second function a minus root 2b cos y into derivative of the first bracket. Derivative of a is 0. Correct? Derivative of root 2b cos x is root 2b minus sin x. 0 minus root 2b into sin x. A and b are constants. A square minus b square is constant. Derivative of constant is 0. Now we can put x equal to pi by 4, y is equal to pi by 4 at this stage. Put x equal to pi by 4, comma, y is equal to pi by 4. What we get? A plus root 2b into cos pi by 4 is 1 by root 2. Second bracket is minus into minus will be plus there. Correct? Root 2b into sin pi by 4 is 1 by root 2 into y dash. Correct? This is a minus root 2b cos y into minus root 2b into sin pi by 4 is 1 by root 2 equal to 0. Correct? Putting the value of x equal to, here I didn't put the value of y, sorry. Y is pi by 4. Cos pi by 4 is 1 by root 2 here. Cos pi by 4 is 1 by root 2. A minus root 2b into 1 by root 2. Correct? Derivative of a minus root 2b cos y. Differentiate this. Derivative of a is 0. Minus root 2b is constant. Derivative of cos y is minus sin y into derivative of y is y dash. Correct? Here, second function into derivative of first. Derivative of a is 0. Derivative of root 2b cos x is root 2b minus sin x. Now you can simplify. Root 2 cancels here. The first bracket is a plus b. Here it is root 2 cancels. B into y dash. Root 2 cancels. A minus b. Correct? Here root 2 cancels. You get minus b is equal to 0. You can divide the entire equation by b. B is positive, right? So b is not equal to 0. You can divide the entire equation by b. I'll get a plus b into y dash. Dividing by b. Divide by b. Dividing by b throughout. Dividing by b throughout. What we get is a plus b into y dash. A plus b into y dash. Plus into minus is minus. A minus b. I'm dividing by b, correct? Equal to 0. So from this y dash means dy by dx. Dy by dx at the point pi by 4 comma pi by 4. I put x equal to pi by 4, y is equal to pi by 4. Getting this as a minus b divided by a plus b. This is dy by dx. I want to find dx by dy. Take reciprocal. Reciprocal of dy by dx is dx by dy. Therefore, dx by dy is dx by dy at pi by 4 comma pi by 4 is. Take reciprocal. What you get is a plus b divided by a minus b. Correct? This is the answer. Answer is option A plus B by A minus B. Question asked on 4th of September, first shift, JEE Main 2020. A plus B by A minus B, taking reciprocal on both sides. Option A. Move on to the next one. Y is given as summation k equal to 1 to 6, k into cos inverse 3 by 5 cos kx minus 4 by 5 sin kx. Want to find dy by dx at x equal to 0. I'll express this in the form of cos of A plus B. Cos of A plus B we know, cos A cos B minus sin A sin B. We know that 3, 4 and 5 are Pythagorean triplets. If you define 3 by 5 as cos alpha, sin alpha will be 4 by 5 because 3, 4 and 5 forms the sides of a right angle triangle, correct? 3, 4 and 5 are the sides of right angle triangle. Call this angle as alpha. This is 3. Cos function defined 3 by 5. Sin will be 4 by 5, correct? Cos function is 3 by 5. This is hypotenuse. This is 3. This is 5, correct? Sorry, this is 4. If cos alpha is 3 by 5, cos alpha is adjacent side by hypotenuse, sin alpha is opposite side by hypotenuse. Cos is adjacent by hypotenuse, sin is opposite by hypotenuse. 4 by 5 is sin alpha, 3 by 5 is cos alpha. So given expression will simplify first. Y is equal to summation of k is equal to 1 to 6, k into cos inverse of what we have 3 by 5, you can write it as cos alpha into cos kx minus 4 by 5 is sin alpha into sin kx. Terms inside the bracket takes the form cos A cos B minus sin A sin B, which is cos of A plus B. So this is summation of k is equal to 1 to 6. Summation k is equal to 1 to 6, k into cos inverse of cos A cos B minus sin A sin B, cos of A plus B, cos of alpha plus kx. Correct? Cos inverse cos of alpha plus kx. I can write it as alpha plus kx by the definition of inverse trigonometry, composition of trigonometric with inverse trigonometry function. So becomes k into, this is alpha plus kx. Multiply this k inside. What we get? Summation k is equal to 1 to 6. K alpha plus k square x is equal to summation of k is equal to 1 to 6 k alpha plus summation k equal to 1 to 6 k square x. Now we can differentiate this. K alpha is constant, no? Summation of k equal to 1 to 6 k alpha is constant. Derivative constant is 0. Differentiate this. dy by dx. dy by dx, derivative of constant is 0. Here constant into variable, constant keep outside. Summation of k square is constant. Summation k equal to 1 to 6, k square is constant, correct? Derivative of x with respect to x is 1. So dy by dx I am getting summation of k square where k is 1 to 6. Summation of n square formula we know, n into n plus 1, 2n plus 1 by 6. Here put n is equal to 6 and write the formula, okay? Constant into variable, constant keep as it is, derivative of x with respect to x1 and derivative constant is 0. Summation of k square, k equal to 1 to 6 is n into n plus 1 into 2n plus 1, 2 into 6, 12 plus 1, 13 divided by 6. 6 cancels. What we get? 7 into 13, which is 91. Numerical type question asked on 2nd of September, second shift, JEE Main 2020. Simplify this using cos A cos B minus sin A sin B. You define 3 by 5 as cos function, so then 4 by 5 will be sin function. So cos A cos B minus sin A sin B, cos of A plus B. So alpha is a constant, so even cos inverse 3 by 5 and sin inverse 3 by 5 are constants, correct? So alpha is a constant. Multiply k inside and differentiate and use the summation of n square formula, n into n plus 1, 2n plus 1 divided by 6. Summation of n square formula. You must learn this if you don't know. Summation of n square is n into n plus 1 into 2n plus 1 divided by 6. Hope it's clear. Move on to the next one. Question number 4. Suppose a differentiable function f of x satisfies this identity given like this for all real x and y. Limit x tends to 0, f of x by x equal to 1. Want to find f dash of 3. So limit x tends to 0, f of x by x is equal to 1 is given. Given limit x tends to 0, limit x tends to 0, f of x divided by x is equal to 1. As x approaches to 0, denominator is becoming 0. So numerator also should tend to 0. I can write f of 0 should be equal to 1. Correct? As x is approaching to 0, as x is approaching to 0, denominator is tending to 0. Implies numerator should tend to 0. Correct? So that limit exists finitely. Otherwise limit does not exist. If denominator is becoming 0, if numerator is non-zero, non-zero by 0 means limit does not exist, becomes infinite. But right answer is already given to be equal to 1, so limit should exist finitely. Because as x is approaching to 0, denominator is becoming 0, numerator also should tend to 0, so that it takes 0 by 0 form. Correct? So f of 0 should be 1. F of 0 should be equal to, as x tends to 0, f of 0 should be equal to 0. Correct? Denominator is becoming 0. Numerator also should tend to 0. When you put x equal to 0, f of 0 should be equal to 0. F of 0 should be equal to 0. Because it takes 0 by 0 form, I can apply L'Hopital's rule here. Correct? Since it takes 0 by 0 form, one can apply L'Hopital's rule. Apply LH rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply LH rule. So what do you get? Limit x tends to 0. Limit x tends to 0. F dash of x divided by derivative of x1. Differentiate numerator and denominator separately. This becomes f dash of 0. Correct? F dash of 0, which is equal to 1. F dash of 0 is equal to 1. Applying L'Hopital's rule. Differentiate numerator and denominator separately. F dash of x by 1. Apply limit f dash of 0. So f dash of 0 is equal to 1. I'll be using this. Okay. Consider this identity given here. F of x plus y is equal to, given identity is f of x plus y is equal to, I can write here itself. Given f of x plus y, f of x plus y is equal to f of x plus f of y, f of x plus f of y plus x into y square plus x square into y. Correct? What we do is we differentiate this partially with respect to x, keeping y as constant. I'll use partial derivative. Otherwise, I can use the definition of derivative of the function. The first principle definition also I can use and get the answer. I'll use the method of partial differentiation. Differentiating with respect to x partially. Differentiating with respect to x partially. Okay? Keeping y as constant. I'm differentiating with respect to x partially. That is keeping y as constant. So f dash of x plus y into derivative of x plus y, derivative of x1, derivative of y is 0 because y is constant here, is equal to f dash of x, f of y is constant, derivative constant is 0. Here y square is constant, y square into derivative of x1, y is constant, derivative of x square is 2x, 2xy. Treating y as constant, differentiate with respect to x partially. Now what I'll do is, you want to find f dash of 3, so I'll find out f dash of x. To get f dash of x, what you do is, you replace y by minus x. Replace y by minus x. Replace y by minus x. What do you get? F dash of x plus minus x. Y is minus x. F dash of x. Correct? Y is minus x. Minus x square is same as x square. Correct? Here 2x into y is minus x. So this becomes f dash of 0, correct? F dash of 0 is equal to f dash of x. Here 2x into minus x becomes minus 2x square. Minus 2x square plus x square, that becomes minus x square. Correct? F dash of 0 is already we know. F dash of 0 is 1 from here. Correct? F dash of 0 is 1. So 1 is equal to f dash of x minus x square. Or you get f dash of x equal to x square plus 1 from this. F dash of x we got. We want to find f dash of 3. So we can put x equal to 3. F dash of 3 is 3 square plus 1. 9 plus 1, which is equal to 10. Numerical type question asked on 4th of September, first shift, JEE Main 2020. Hope it's clear. Move on to the next one. This is a question based on the functional equation. I'm differentiating with respect to partially, keeping y as constant. You have dash of x plus y into derivative of x plus y is 1 because y is treated as constant. Y is treated as constant. Derivative of f of x, f dash of x. Derivative of f of y is 0. Y square you keep as it is because it is a constant. Derivative of x with respect to x1. Here y is constant. Derivative of x square is 2x. So 2xy. Then replace y by minus x. Put y as minus x plus minus x 0. F dash of x keep as it is. Y is same as minus x. Minus x the whole square same as x square. 2x into minus x. So minus 2x square plus x square becomes minus x square. F dash of 0 is 1 we got here. So f dash of x is 1 plus x square. F dash of 3 we want 3 square plus 1. 9 plus 1 10. Okay, move on to the next one. Question number 5. A function f from R to R is defined like this. The value of lambda for which f double dash of 0 exists. Question asked on 6th of September, first shift, JEE Main 2020, numerical type question. So, we'll find out the derivative here. F dash of 0 minus and f dash of 0 plus. Okay, x greater than 0 is 0 plus. X less than 0 is 0 minus. Find out f dash of x for x less than 0. For x less than 0, f dash of x is equal to how much? F dash of x. Here you can apply the product rule here. First into derivative of second plus second into derivative of first. X power 5 into derivative of sine 1 by x is cos 1 by x into derivative of 1 by x is minus 1 by x square. Plus second function into derivative of first, that 5x power 4 into sine 1 by x. Correct? And derivative of 5x square is 10x. First into derivative of second, derivative of sine 1 by x, cos 1 by x into derivative of 1 by x minus 1 by x square plus second function into derivative of first, derivative of x power 5 is 5x power 4, derivative of 5x square is 10x. Now we can simplify this one step. This will be equal to x square will cancel, so I'll get minus x cube into cos 1 by x plus 5x power 4 into sine 1 by x plus 10x. Now I'll double differentiate. Differentiate this once again with respect to x. You have double dash of x minus of x cube into derivative of cos 1 by x is minus sine 1 by x into derivative of 1 by x is minus 1 by x square minus sine of 1 by x minus sine of 1 by x into derivative of 1 by x is minus 1 by x square plus cos 1 by x into derivative of x cube is 3x square. 3x square into cos 1 by x. Okay, you can close the bracket here. Plus 5 into 5 you can keep outside. Apply the product rule here. X power 4 into derivative of sine 1 by x cos 1 by x into derivative of 1 by x is minus 1 by x square plus sine 1 by x into derivative of x power 4 is 4x cube. 4x cube into sine 1 by x. Correct? First into derivative of second, derivative of sine 1 by x, cos 1 by x into derivative of 1 by x is minus 1 by x square plus second function into derivative of first, derivative of x power 4 is 4x cube and derivative of 10x is 10. Now we can see that you have double dash of 0 minus. If you apply limit for this, this is becoming 0. 0 into sine 1 by x is a finite number. X tends to 0 plus or 0 minus, whatever. Sine of 1 by x is an oscillating value. It lies between minus 1 plus 1, including the endpoints. So this into 0 becomes 0. Even though x square cancels, x into sine 1 by x becomes 0. Correct? Here 3 into 0 into finite number 0. 1 x square will cancel, 0 into some finite number 0. 0 into finite number 0. All the terms become 0 here. F double dash of 0 minus. So I am getting F double dash of 0 minus as 10. F double dash of 0 minus is 10, putting x equal to 0. That means you are applying limit here. Okay, second derivative you are finding by applying limit x tends to 0. Okay, x tends to 0 minus you apply, you'll get like this. And you have double dash of 0 plus if you want, you differentiate this same way. For x greater than 0, for x greater than 0, f of x is given to be equal to, f of x is x power 5 into cos 1 by x, x power 5 into cos 1 by x plus lambda into x square. Correct? You have dash of x you find out. You have dash of x. first into derivative of second. Derivative of cos is minus sine of 1 by x into derivative of 1 by x, which is minus 1 by x square, plus cos 1 by x into derivative of x power 5 is 5x power 4. Close the bracket. Derivative of lambda x square, 2 lambda x. You can simplify one step here, correct? First into derivative of second. I think I should have closed the bracket here itself. Closing the bracket is not proper. I can close the bracket here itself. Correct? First function keep as it is. Derivative of cos 1 by x minus sine 1 by x into derivative of 1 by x minus 1 by x square, plus second function into derivative of x power 5 is 5x power 4. So we can write this as minus into minus will become plus here. So we have dash of x will be in the simplified form x cube into sine 1 by x, x cube into sine 1 by x, correct? Minus into minus plus, x square got cancelled, x cube into sine 1 by x plus 5x power 4 into cos 1 by x plus 2 lambda into x. Now find out f double dash of x. F double dash of x is x cube into derivative of sine 1 by x is cos 1 by x into derivative of 1 by x is minus 1 by x square, correct? Plus sine 1 by x into derivative of x cube is 3x square. First into derivative of second, derivative of sine 1 by x, cos 1 by x into derivative of 1 by x is minus 1 by x square. Plus second function keep as it is, derivative of x cube is 3x square. Coming to this part, 5 into, apply the product rule, x power 4 into derivative of cos 1 by x is minus sine 1 by x into derivative of 1 by x, which is minus 1 by x square, plus cos 1 by x into derivative of x power 4 is 4x cube. Derivative of 2 lambda x is 2 lambda, correct? If you want, you can simplify this. Here x square is going to cancel, minus x cos 1 by x. As you apply limit, no, 0 into some finite number, 0. Sin 1 by x and cos 1 by x are finite number, lies between minus 1 plus 1, including the endpoints as x tends to 0 plus or 0 minus. 0 into some finite number, 0. 0 into some finite number, 0. Here x square cancels, x square remains, x square is becoming 0, 0 into finite number, 0. Here x cube is becoming 0, 0 into finite number 0. So you have double dash of 0 plus will be equal to 2 lambda. You have double dash of 0 plus will be 2 lambda, correct? The function you have double dash of 0 exists means left hand derivative should be equal to right hand derivative, correct? Given you have double dash of 0 exists finitely. You have double dash of 0 exists, implies what you can write is left hand derivative at 0 should be equal to right hand derivative at 0. Left hand derivative at 0 got it as 10. Right hand derivative is 2 lambda. 2 lambda is equal to 10. That means lambda is equal to 5. So value of lambda is equal to 5 getting. Second derivative at x equal to 0 exists if the value of lambda is 5. Question answered on 6th of September, first shift, JEE Main 2020. Hope it's clear. For x less than 0, take this. Differentiate. First function keep as it is, derivative of sine 1 by x, cos 1 by x into derivative of 1 by x minus 1 by x square, plus second function keep as it is, sine 1 by x, derivative of x power 5 is 5x power 4, derivative of 5x square 10x. So simplify this, 1x square got cancelled, minus x cube cos 1 by x, 5x power 4 sine 1 by x plus 10x, minus you keep outside. Again differentiate by using product rule. First function keep as this, derivative of cos 1 by x minus sine 1 by x into derivative of 1 by x minus 1 by x square, plus cos 1 by x into derivative of x cube is 3x square. Here 5 you keep outside. Again apply product rule. First function keep as this, derivative of sine 1 by x cos 1 by x into minus 1 by x square, plus second function keep as it is, derivative of x power 4 is 4x cube, derivative of 10x is 10. And when I apply limit as x tends to 0 minus, all the terms will become 0 because 0 into any finite number is 0. What remains is 10. Same way here. For x greater than 0, consider this function f of x. X power 5 into cos 1 by x plus lambda into x square. First into derivative of second. Derivative of cos 1 by x minus sine 1 by x into derivative of 1 by x minus 1 by x square. Plus second function keep as it. Derivative of x power 5 is 5x power 4. Derivative of lambda x square is 2 lambda x. This is minus into minus will become plus 1x square got cancelled, x cube into sine 1 by x plus 5x power 4 into cos 1 by x, correct? This is kept as it is here, plus 2 lambda x. Now again double differentiate. First into derivative of second. Derivative of sine 1 by x cos 1 by x into derivative of 1 by x minus 1 by x square plus sine 1 by x into derivative of x cube is 3x square. 5 is constant, keep outside. Differentiate by using product rule. First function keep as it is. Derivative of cos 1 by x minus sine 1 by x into derivative of 1 by x minus 1 by x square plus cos 1 by x into derivative of x power 4x cube. Derivative of 2 lambda x is 2 lambda. You have double dash of 0 plus. All these terms will become 0 because 0 into finite number is 0. As x tends to 0 plus or 0 minus. In both the case, sine 1 by x and cos 1 by x are finite values lying between minus 1 and plus 1. So I'm getting this as 2 lambda. Equate this equal to this. 2 lambda equal to 10 implies lambda equal to 5. Move on to the next one. X is defined in terms of theta, y is also defined in terms of theta. Parametric equations are given. Want to find dx by d theta, dy by d theta, then find dy by dx, then find the second order derivative. Dx by d theta by parametric differentiation. Dx by d theta is equal to derivative of 2 sin theta is 2 cos theta. Correct? Derivative of sin 2 theta is cos 2 theta into 2. So 2 cos 2 theta. dy by d theta is constant into variable. Derivative of 2 cos theta is minus 2 sin theta. Correct? Derivative of cos 2 theta is minus sin 2 theta into 2. Minus of minus becomes plus 2 sin 2 theta. Correct? Now we can find out dy by dx. Then find d square y by dx square. Therefore dy by dx equal to dy by dx equal to dy by d theta divided by dx by d theta. Dy by d theta divided by dx by d theta. Dy by d theta is there. 2 is common there. So what it means is sin 2 theta minus sin theta divided by dx by d theta. Take 2 common there. Cos theta minus cos 2 theta. 2 cancels. What you get is sin 2 theta minus sin theta by cos theta minus cos 2 theta. Sin 2 theta minus sin theta divided by cos theta minus cos 2 theta dy by dx. Correct? Now you can find out the second order derivative d square y by dx square. Therefore d square y by dx square is equal to d by dx of dy by dx. Correct? D by dx of dy by dx. This is equal to d by dx of dy by dx. We got sin 2 theta minus sin theta. Sin 2 theta minus sin theta divided by cos theta minus cos 2 theta. Apply quotient rule for this. Using quotient rule for this. Denominator square. Denominator square. Correct? Denominator into derivative of numerator minus numerator into derivative of denominator. Correct? So I'll apply this. I'll write short forms, otherwise I'll write fully, no problem. Cos theta minus cos 2 theta. Cos theta minus cos 2 theta, denominator into differentiate numerator, derivative of sin 2 theta is 2 cos 2 theta minus derivative of sin theta is cos theta. Correct? Differentiate the numerator, 2 cos 2 theta minus cos theta minus numerator into sin 2 theta minus sin theta into differentiate the denominator. Derivative of cos theta is minus sin theta. Derivative of cos 2 theta is minus sin 2 theta into 2. Minus of minus becomes plus 2 sin 2 theta. Plus 2 sin 2 theta. Okay, I wrote like this. Into d theta by dx. Further I should multiply by d theta by dx. Reciprocal of dx by d theta. Correct? I need to multiply by d theta by dx because I am differentiating with respect to x. I am differentiating with respect to x. Otherwise I'll rub and write properly. Just taking more space here. Correct? You can start from extreme left side so that no need to write in the second line. So what do you get here? This is equal to, use quotient rule here, denominator square, cos theta minus cos 2 theta the whole square. Denominator square. Denominator keep as it is, cos theta minus cos 2 theta. Correct? Denominator keep as it is, differentiate numerator. Derivative of sin 2 theta is 2 times cos 2 theta. Minus derivative of sin theta is cos theta. Differentiating the numerator. Minus numerator into differentiate the denominator. Minus sin 2 theta minus sin theta into differentiate the denominator. Derivative cos is minus sin theta. Derivative cos 2 theta is minus sin 2 theta into 2. Minus of minus plus 2 sin 2 theta. 2 sin 2 theta. Okay. This is multiplied by d theta by dx into d theta by dx. I'll write in the next line. Now we can substitute the value at theta equal to pi. You need to find, no? Therefore, d square y by dx square at theta is equal to pi. At theta is equal to pi. Put theta equal to pi. You must know the values. Sin pi and sin 2 pi both are 0. Cos pi is minus 1. Cos 2 pi is plus 1. If you were to write the values here. Cos pi is minus 1. Cos 2 pi is plus 1. Cos of odd pi is minus 1. Cos of even pi is plus 1. Sin of every pi is 0. Sin pi is 0. Sin of every multiple of pi is 0. Sin 2 pi is also 0. Correct? So this becomes cos pi is minus 1. Cos 2 pi is 1. Correct? Here cos 2 pi is 1. Cos of 2 into pi. 2 into 1 is 2. Cos pi is minus 1. Minus of minus becomes plus 1. And here it becomes 0. Sin 2 pi is 0. Sin 0 is 0. 0 minus 0 is 0. That part is gone. Correct? This part is 0. Divided by cos pi is minus 1. Cos 2 pi is 1. The whole square into d theta by dx. D theta by dx reciprocal of this. Cos pi is minus 1. Correct? 2 into minus 1. This will become how much? When you put theta equal to pi. 2 into minus 1. Cos pi is minus 1. Minus 2 into cos 2 pi is 1. So I get minus 2 minus 2 minus 4. So minus 1 by 4 into minus 1 by 4. Reciprocal of that. How much you get? That's equal to minus 1 is minus 2. 2 plus 1, 3. Divided by minus 2 square, which is 4. Into minus 1 by 4. Minus into minus becomes plus. 3 into 2 is 6. 4 into 4 is 16. So we get the answer as 3 by 8. 3 by 8. Option C. Question asked on 9th of January, second shift, 2020, JEE main. Move on to the next one. Derivative of tan inverse root 1 plus x square minus 1 by x with respect to tan inverse of 2x into root 1 minus x square by 1 minus 2x square. Derivative of one function with respect to another function. Take the first function as u and second function as v. Let u be equal to, u is equal to tan inverse of square root of 1 plus x squared minus 1 by x. You can put x equal to tan theta here and simplify. This question is there in the NCERT exercise itself, in inverse trigonometry function chapter. Simplified form, it's better to remember. Answer is half tan inverse x. By putting x equal to tan theta, this will simplify to half tan inverse x. Put x equal to tan theta if you want. 1 plus tan square, secant square, root of secant square, secant theta minus 1 by tan theta. Secant is 1 by cos, tan is sin by cos. Go on, simplify. You'll end up with getting half tan inverse x. So very important. Please remember it. Please remember. Half tan inverse x. Okay. Take the second function as v here. Let v be equal to this. Let v is equal to tan inverse of 2x into root of 1 minus x square. 2x into root of 1 minus x square divided by 1 minus 2x square. Here we'll make a substitution, put x equal to sine theta, because this takes the form 2 sine theta cos theta. When you put sine theta, no, numerator becomes 2 sine theta root of 1 minus sine square theta. Root of 1 minus sine square theta is cos theta. 2 sine theta cos theta is sine 2 theta. Denominator is 1 minus 2 sine square theta, which is cos 2 theta. So put x equal to sine theta and simplify this. Put x equal to sine theta. What we get? V is equal to, therefore V is equal to tan inverse of 2 sine theta into root of 1 minus sine square theta divided by 1 minus 2 sine square theta, putting x equal to sine theta is equal to tan inverse of, what we get is 2 sine theta, 1 minus sine square is cos square, root of cos square is cos, assuming that it is positive, 1 minus 2 sine square theta is cos 2 theta. Numerator is 2 sine theta cos theta, which is sine 2 theta. Tan inverse of sine 2 theta divided by cos 2 theta. Sine 2 theta by cos 2 theta is tan 2 theta. Tan inverse of tan 2 theta is equal to 2 theta. Substitute back for theta, because you put x equal to sine theta, retrieve it back. Theta is sine inverse of x. Theta is sine inverse of x. So this becomes equal to 2 into sine inverse of x. Now simplified form of u is half tan inverse x. Simplified form of v is 2 sine inverse x. You can find out du by dv. Therefore du by dv is du by dx by dv by dx. Du by dv is du by dx divided by dv by dx, derivative of the first function with respect to second function. Du by dx you can find out from this. Constant into variable. Constant keep as this. Derivative of tan inverse x, 1 by 1 plus x square. So half into 1 by 1 plus x square. dv by dx. Constant into variable. Constant keep as this. Derivative of tan inverse x, 1 by root of 1 minus x square. Now we can put x equal to half, correct? Du by dv at x equal to half we need to find. Put x equal to half. What do you get? 1 by 2 by 2 will be 1 by 4, correct? This you can write one more step if you want. 1 by 2 by 2 will be 1 by 4. This root 1 minus x square goes to numerator. Root of 1 minus x square divided by 1 plus x square. Like this we get. So we get 1 by 4 into root of 1 minus half square is 1 by 4 divided by 1 plus, what you get is 1 by 2 square is 1 by 4. Simplify this. 1 minus 1 by 4 is 3 by 4. Root of 3 by 4 is root 3 by 2. Correct? This will be 1 by 4 into root 3 divided by 2. 1 plus 1 by 4 is 5 by 4. Correct? This 4 and 4 I can cancel. This 2 comes to denominator. So root 3 divided by 5 into 2 is 10. Root 3 by 10 is answer. Root 3 by 10, option D. Question asked on 5th of September, second shift, JEE Main 2020. Okay. This 2 comes to denominator, this goes to numerator. Put x equal to half. Half square is 1 by 4. 1 minus 1 by 4, 3 by 4. Root of 3 by 4 is root 3 by 2. 1 plus 1 by 4 is 5 by 4. 4 cancels. 2 comes down. Root 3 by 10. Option D is answer. Move on to the next one. Question number 8. If alpha is given, I think it should be y of alpha here. Y of alpha is given as, you can call it as y itself. Y of alpha is given as like this. Want to find dy by dx at alpha equal to 5 pi by 6. So y as a function of alpha. Y of alpha is equal to square root of 2 into tan alpha plus, we can write cot alpha as 1 by tan alpha there. Cot is reciprocal of tan, right? So 1 by tan alpha. We'll simplify this first. Divided by 1 plus tan square alpha is there. Plus, here 1 by sine square alpha is cosecant square alpha. Is equal to square root of 2 into, take LCM, tan alpha is tan alpha by 1. So LCM is tan alpha. Correct? Tan alpha into tan alpha. Tan square alpha plus 1. Tan square alpha plus 1. divided by 1 plus tan square alpha plus cosecant square alpha, we can write 1 plus cot square alpha, correct? 1 plus cot square alpha. Here 1 plus tan square alpha is going to cancel, correct? 1 plus tan square alpha cancels. 2 by tan alpha, which is 2 into cot alpha. So I am getting like this, root of, this is 2 into 1 by tan, which is cot. 2 cot alpha plus 1 plus cot square alpha, which is a square plus b square plus 2ab, which is a plus b the whole square. So this is cot alpha plus 1 the whole square, completing the square. As I told earlier many times, root of x square is equal to mod x, correct? And mod x is equal to x if x is greater than or equal to 0. Mod x is minus x if x is less than 0. See whether the terms inside the root is positive or not. Root of 1 plus cot alpha whole square. This becomes mod of 1 plus cot alpha. Mod of 1 plus cot alpha. Root of x square is mod x. Root of 1 plus cot alpha whole square is mod of 1 plus cot alpha. Where is alpha? Alpha lies in the interval 3 pi by 4 to pi, which is a part of second quadrant. Second quadrant cot function is negative. Correct? Tan and cot both are negative in the second quadrant. We are interested in cot function here. So cot 3 pi by 4 is minus 1. Cot is a decreasing function. Cot 3 pi by 4 is minus 1. And in the interval 3 pi by 4 to pi, cot function is decreasing. In the second quadrant, the cot function is decreasing. Derivative of cot x is minus cosecant square x. Of course, cot function is decreasing in each quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. In every quadrant, cot function is decreasing. So remember that. So in the second quadrant, it's a part of second quadrant. It's decreasing function. Cot 3 pi by 4 is minus 1 and cot pi is tending towards minus infinity. Okay. So 1 plus cot alpha is negative in that interval. Okay. If you take value of alpha greater than 3 pi by 4, say you take 5 pi by 6. If you take cot 150 degree, 150 degree lies in this, correct? 135 to 180, this angle in terms of degrees. So 150 degree if you calculate, cot 150 will be minus cot 30, minus cot 30 which is minus root 3. So 1 plus minus root 3, it's negative. 1 minus root 3 is negative. So terms inside the mod is negative. So mod of x will be minus x if x is negative. So 1 plus cot alpha is negative in this interval. Note that 1 plus cot alpha is less than 0. Note that 1 plus cot alpha is going to be less than 0. Correct? For all alpha belonging to the interval 3 pi by 4 to pi. So 1 plus cot alpha negative is mod of 1 plus cot alpha becomes minus of 1 plus cot alpha. Minus of 1 plus cot alpha. Now we can differentiate with respect to alpha. Y of alpha is given. I want to find dy by dx. Dy by d alpha it is actually. Dy by d alpha because it's a function of alpha, correct? So dy by d alpha you can find out. It's a function of alpha. Therefore, y of alpha simplifies to minus 1 minus cot alpha. Differentiate this with respect to alpha. Dy by d alpha. With respect to alpha I find out. Derivative of minus 1 is 0. Derivative of cot is minus cosecant square. Minus of minus becomes plus cosecant square alpha. Correct? Is equal to cosecant square alpha. Want to find at alpha equal to 5 pi by 6. D square dy by d alpha at alpha equal to 5 pi by 6. At alpha equal to 5 pi by 6. Cosec 5 pi by 6. Cosec 5 pi by 6 is 2. Correct? Sin 5 pi by 6 half. 5 pi by 6 is 150 degree which lies in second quadrant. Second quadrant sin and cosec both are positive. Cosec 5 pi by 6 simplifies to 2. This is 2 square. 2 square is 4. Answer is 4. Option C. Question answered on 7th of January, first shift, JEE Main 2020. Hope it's clear. Okay. Important step is this. Mod of 1 plus cot alpha is minus of 1 plus cot alpha. If you write 1 plus cot alpha directly, if you write root of 1 plus cot alpha whole square as 1 plus cot alpha, you will get derivative as minus cosecant square alpha, which is minus 4 will get, which is wrong. Minus 4 is wrong answer. 4 is the right answer. Important step is this. Learn this important. Root of x square is mod x. And mod x is x, mod x is x if x is greater than or equal to 0. Fundamental definition of modulus function. Mod x is minus x if x less than 0. So mod of 1 plus cot alpha is going to be minus of 1 plus cot alpha, because 1 plus cot alpha is negative for all alpha belongs to this interval 3 pi by 4 to pi. Please make a note of this. Quite important. Move on to the next one. Question number 9. X power k plus y power k equal to a power k. A and k are positive real numbers. And dy by dx plus y by x power 1 by 3 is equal to 0. Find k is equal to how much? So differentiate this. Given x power k plus y power k equal to a power k. X power k plus y power k is equal to a power k. Differentiate with respect to x. Differentiate with respect to x on both sides. What do I get? K into x power k minus 1. Here k into y power k minus 1 into y dash. Derivative of a power k is 0. From this we can write k into x power k minus 1 is equal to minus k into y power k minus 1 into y dash. K cancels. So I'll get y dash is equal to minus x power k minus 1 divided by y power k minus 1. Correct? Dy by dx or y dash is equal to minus x power k minus 1 divided by y power k minus 1. I can write dy by dx from this as minus of y by x power 1 by 3. What is given also dy by dx from the given data, from the given question, dy by dx is equal to what? Minus y by x power 1 by 3 minus y by x to the power 1 by 3. Dy by dx I'm getting minus of y by x power 1 by 3. This dy by dx could also be written as minus y power k minus 1, take it to numerator, becomes y power 1 minus k divided by x power k minus 1, bring it to denominator, becomes x power 1 minus k. Correct? So this is equal to minus y by x to the power 1 minus k. Y by x to the power 1 minus k. K minus 1, take it up. Y power k minus 1 taken up becomes y power 1 minus k. X power k minus 1 brought to denominator becomes x power 1 minus k, which could be written as minus of y by x power 1 minus k. Already this is given. So compare. Dy by dx is given to be equal to minus y by x to the power 1 by 3. See, bases are same, therefore the power should be same. This is given in the question. Correct? So bases are same, so power should be same. 1 minus k should be equal to 1 by 3. What I get is 1 minus k is equal to 1 by 3. This gives k is equal to 1 minus 1 by 3, which is 2 by 3. So value of k is 2 by 3. Value of k is 2 by 3. Option C. Question asked on 7th of January, first shift, JEE Main 2020. Hope it's clear. Just differentiate with respect to x on both sides. Derivative of x power k into x power k minus 1. Derivative of y power k into y power k minus 1 into derivative of y is y dash. Derivative of constant is 0. A power k is a constant. Derivative of constant is 0. So k into x power k minus 1 is equal to, this is shifted to that side, minus k y power k minus 1 into y dash. K cancels. So y dash is minus of x power k minus 1 divided by y power k minus 1, which also could be written as minus y power 1 minus k divided by x power 1 minus k. Compare with this. Bases are same, therefore power should be same. So 1 minus k should be equal to 1 by 3. K is equal to 2 by 3. Move on to the next one. Question number 10. Given, let y equal to y of x be a function of x satisfying this, where k is a constant, y of half equal to minus 1 by 4. Want to find dy by dx at x equal to half. So differentiate this equation. Given y into root of 1 minus x square, y into root of 1 minus x square is equal to k minus x into root of 1 minus y square. Correct? We can rewrite this equation and convert it to in terms of putting x equal to cos alpha and sin alpha. That also we can do. There are two ways of doing this problem. I can rewrite this equation as y into root of 1 minus x square, correct, plus x into root of 1 minus y square is equal to k. Okay, Rewrite this equation. I can use sin inverse on both sides. Putting sin inverse on both sides. What do you get? Sin inverse of, applying sin inverse on both sides. Sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. Applying sin inverse on both sides is equal to sin inverse of k. Assume that k lies between minus 1 and plus 1, including 9 points. So this becomes what? Sin inverse of x plus sin inverse of y, using our formula. Sin inverse of x plus sin inverse of y is equal to sin inverse of k. Correct? Differentiate this with respect to x on both sides. Differentiate with respect to x. Derivative of sin inverse of x is 1 by root of 1 minus x square. Derivative of sin inverse of y is 1 by root of 1 minus y square into y dash. Derivative of constant is 0. So from this I can write 1 by root of 1 minus x square. 1 by root of 1 minus x square is equal to, shift this term to the other side, minus 1 by root of 1 minus y square into y dash. So from this, y dash is equal to what? Y dash is equal to minus root of 1 minus y square divided by root of 1 minus x square. Want to find the derivative at x equal to half. When x is half, y is minus 1 by 4. That if you want, you can find out. That's given to be in the question, correct? When x is half, y is minus 1 by 4. So put x equal to half, y equal to minus 1 by 4. Put x equal to half and y is equal to minus 1 by 4. We'll get y dash. Y dash is equal to minus root of 1 minus 1 by 4 square, that is 1 by 16, divided by root of 1 minus 1 by 2 square, 1 by 4 is equal to minus root of 1 minus 1 by 16 is 15 by 16. 1 minus 1 by 4 is 3 by 4. Correct, this becomes minus root 15, I can write root 3 into root 5. And root 16 is 4. Correct, divided by root 3 divided by root 4 is 2. Correct, root 3 cancels. 2 ones are 2 twos are. I'll get the answer as minus root 5 divided by 2. 2 ones are 2 twos are. Root 3 cancels. Minus root 5 by 2. Option C. We can do directly also. You can use the implicit function differentiation and differentiate. I mean, you can use the product rule here and also the product rule here. I'm taking sin inverse on both sides. Becomes easy. Sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square is sin inverse of x plus sin inverse of y if the condition both x and y are positive actually, and x square plus y square should be less than 1. Okay, here of course y value is negative, but still I have applied it. I am getting the answer, right answer. When x is half, y is minus 1 by 4. Okay, so of course x square plus y square less than 1, that condition is there, you can check. X square plus y square, 1 by 2 square is 1 by 4, 1 by 4 square is 1 by 16, 1 by 16 plus 1 by 4 less than 1, sure. So I could apply this formula. You can replace y by minus y, still I can apply x square plus y square is less than 1, that condition is satisfied. So doesn't matter, so answer is minus root 5 divided by 2, correct? Putting x equal to half and y equal to minus 1 by 4. Cross multiply this, dy by dt, this term is shifted to that side. So dy by dx or y dash is minus root of 1 minus y square by root of 1 minus x square. This entire thing is taken to that side, correct? So y dash is minus root of 1 minus y square by root 1 minus x square. X equal to half, y is equal to minus 1 by 4. Minus 1 by 4 square is 1 by 16. Half square is 1 by 4. 1 minus 1 by 4, 3 by 4. 1 minus 1 by 16 is 15 by 16. Root of 15 by 16 is root 15 by 4. This is root 3 by 2. Root 3 cancels. 2 ones are 2 twos are minus root 5 by 2. Any other method also you can try. Okay. Move on to the next one. I think this is the last question of the 2020 paper covering both January shift and September shift. Okay. F and G be two differentiable functions on R such that F composition G is an identity function. Given F composition G is an identity function. F composition G is an identity function. That means you can write f of g of x is equal to x. F of g of x is equal to x. Okay. And further, for some a comma b belongs to R, g dash of a is phi, g of a is equal to b. Want to find f dash of b. So want to find f dash of b. So differentiate this with respect to x by chain rule. Derivative of composite function. Differentiate with respect to x on both sides. What do you get? This will become f dash of g of x into derivative of g of x is g dash of x and derivative of x with respect to x1. So what we get? What I'll do is, because I want to find f dash of b, I'll put g of x as b. Okay, g of x equal to b. I'll put g of x is b. If you put g of x as b, I'll put g of a, g dash of a I want to find. That means I'm putting x equal to a. In fact, I'll show the one more step here. Put x equal to a. Put x equal to a. Put x equal to a. So this becomes f dash of g of a into g dash of a is equal to 1. Putting x equal to a. G of a is given to be equal to b, no? So this becomes b here. Correct? So what I'm getting is f dash of g of a is b into g dash of a equal to 1. I need to find f dash of b. So from this I can write f dash of b is equal to 1 by g dash of a. F dash of b. I'm putting x equal to a and using g of a equal to b for this. G of a is equal to b and f dash of b is I want to find out. G dash of a, I'm putting x equal to a, g of a is b. When you put x equal to a, I get like this. Put x equal to a, put x equal to a. G dash of a keep as this. G of a is given to be equal to b. So use that. And f dash of b becomes 1 by g dash of a. F dash of b is 1 by g dash of a, which is equal to 1 by g dash of a is equal to 5. Correct? So this becomes 1 by 5. So f dash of b they ask, which is equal to 1 by 5. Option D. Question asked on 9th of January, second shift, JEE Main 2020. With this we completed all the questions completely. We solved of the paper 2020 of the chapter differentiation. I'll be covering all the PYQs from 2019 to 2025 conducted by NTA. Please work out all the questions. It's very beneficial because many times questions do repeat of the same type. Same type of questions will be asked many times. So that becomes a very good practice. First study the synopsis completely of all the chapters and work out the problems of PYQs only at first. So that's the best way of preparing for JEE exams. Definitely works. Okay. With this we completed all the questions. This is the 10th one, correct? 9th. Question number 9 was this. Question number 8. Question number 7, then we had 6, parametric form with second order. Question number 5, question number 4, functional equation question. Question number 3 on inverse trigonometric with summation, implicit function, and first question was also on implicit. So all the 11 questions were solved in detail along with the explanation, okay, covering both January and September shift of the chapter differentiation in the year 2020. These questions were asked, okay, of JEE main exam. So many more videos will be uploaded in the coming days focusing on JEE mains as well as KCT, NDA and even NCERT of both first PU and second PU. Please subscribe to my channel, forward to your friends and please share it to all to your friends so that it is beneficial to each one of you. Okay, with this I conclude. Thank you.